Hello. In this video, let us discuss about left rotation and right rotation in a list, and we'll take a basic example. And through this, this is quite an handy exercise to do to understand how actually the slicing of a list operates upon. Right. So, like let's say if we have n equal to one, here from the original source of list, the original of list is left rotated. So whenever we perform a left rotation, the zero index element will come at the last index element, and all of the rest of the element will be shifted to uh, by one towards left, right? So this is how we will get 2 3 4 and 1. Now let's suppose n equal to 2. So yet again 1 and 2 will be left rotated, and 3 and 4 will come over here. And like let's say if we have n equal to 6, so this again becomes n equal to 2 only. Basically, whenever your n exceeds the value of 4, so in that case you need to use the modulo operator and just get the remainder. So basically 6 modulo 4 will give you 2, and this will again move back to how n equal to 2 is functioning, right? So the code of this is this whole problem is fairly simple. You do not have to go and write a for loop and everything. If you understand how this thing is functioning, so here basically the zeroth index, depending upon the n, the zeroth index is placed at the last index, and all the rest of the element is placed at the index from the n minus 1, right? So let's consider k as our n element, and k is or let's consider n only. N is equal to 1, and the arr is 1 comma 2 comma 3 comma 4, right? We put a basic condition: if n is greater than 4, so n mod equal to 4. Now what we need to do, we just need to do arr of n colon plus arr of colon n. So by this, what we have done, n is equal to 1, and over here we consider all of the rest of the element, and that will automatically get left rotated, and all the element up to the n x, that will be passed on in the rightmost part of this array, right? And this is all you need to do to perform a left rotation of a list. We can see this in Python 3 solutions.py. 2341, we are able to achieve the adequate output. If I change the value to n equal to 2, this will give me 3412. If I choose n equal to 3, this will give me 4123, right? Now similarly, how we did the left rotation, when we can do the right rotation. For the right rotation, the output would look like, let me print this out for you. Right. So in right rotation, in the left rotation, what was happening, the zeroth element was getting shifted, and all the rest of the element was relatively being shifted towards left, right? So over here the complete opposite will happen. Actually 4 will be 4 will come here. So here 4 reaches here, and all the rest of the element 1 comma 2 comma 3. For n equal to 2, the output remains the same, but you need to understand how the right rotation is functioning, right? And for n equal to 6, again the output remains the same. So for our demo purpose, let's have n equal to 7, which is basically equivalent to n equal to 3. And in n equal to 3 case, uh, 2 3 4, this should be coming at the first interval of the list, and whatever remains comes at the last interval of the list. Okay. So again the slicing operation will be performed on over here. So as you can see, this was supposed to be the minus one element, right? And all of the rest of the element is reaching up to the minus nth element. So here we go minus n colon. So in this case minus n colon, so minus 1 followed by whatever is coming after this. So nothing is coming after this, so only 4 will come. And similarly all of the element until the minus nth index element, right? So let me have the n value as 1, and let me execute this. So at n equal to 1, for left rotation our output was supposed to be 2 3 4 1. At n equal to 1, our output is supposed to be 4 1 2 3. Similarly, if I do n equal to 7, right? So here we are presented a list like this. We need to rotate all the element that has the value 0 to right hand side of this list, right? While maintaining all the non-zero element index. So basically 1 2 3 4 will come here, and all the zero element needs to be present at the rightmost part of this list. Okay. One key constraint: you cannot use any other list in order to achieve this output. You need to perform the in place operation, right? So this can be easily done actually. We just need to declare input list as this. Then we iterate through this element, and we will have to use the syntax idx comma val in enumerate, because we need the index pointer. If the val is equal to 0, what we can do, we can simply remove that element, and let's consider this as 0 element, right? So that element basically, at this iteration, one was there. So for one this condition hadn't met, our iteration moved further. For index 1, this condition was met and this element was popped off. Whenever we perform any pop operation, by default there is this left and right rotation that is taken care of internally. So as soon as that was popped up, two automatically got left rotated. Now what we need to do, we just need to append this 0, uh, and when we perform the append operation, this will by default go towards the rightmost section of this list. So we just need to do input list dot append 0 element, right? So I can print this now. I'll execute this python 3 solution.py. This is what we wanted. I hope this video was useful. Thank you.